Hello, good day. Today we'll be discussing about fuels and combustion, and we'll be dealing about fossil fuels and how to determine the air fuel ratio for a complete combustion, as well as the masses of flue gases that will be produced. So we will be still be using this book by Deepak Sarkar, Thermal Power Plant Design and Operation. Okay, so to start, what are fossil fuels? So fossil fuels are composed of hydrogen and carbon. Okay, so these are the main combustible elements. So it is classified into coal and petroleum. So from the word itself, fossil, it is formed from the fossilized remains of dead plants and animals. So these plants and animals are buried underneath, and due to the extreme heat and pressure in the Earth's crust, it is formed into uh, sedimentary rocks or plants, no? Which is coal, and turned into liquid petroleum or natural gas. So when dead plants are uh, decomposed and under extreme heat and pressure, over time it becomes coal. So coal actually are sedimentary rocks. Okay. So how about the dead animals? Ang mga dead animals will turn into liquid petroleum, no? Again, kuha na po niya siya, no? Sagol-sagol na niya sa mga other minerals. And over time, for coal, mahimo siyang mature siya, and then ma-increase ang iyang carbon content. Okay, so different fuels are characterized by its heating value. Okay, so there are two types of heating values. You have higher heating value and the lower heating value. Now, this heating value is the heat amount of heat that is recovered when you combust, sample 1 kilogram of fuel, and you allow it to undergo complete combustion. Now, these uh, combustion gases, if you allow it to return back to its initial temperature, amount of heat na maka-recover ato will be the higher heating value. Now, the lower heating value can get it by subtracting the heat of vaporization. Okay, so sa higher heating value, it is assumed that the amount of water vapor in the gases condenses back to water. So, anong mas dako siya og value. So, kung isubtract nimo ang uh, heat of vaporization sa water adto, you can get the lower heating value. Now, in order to grasp say difference aning mga heating value sa mga fuel, let's compare. You have a 1 kilogram of uranium fuel. Now, this 1 kilogram of uranium fuel, it will generate about 85 times 10 to the 6 megajoules of heat, no? So imagine for just 1 kilogram of fuel, you can now get this tremendous amount of energy. Now, how about if you use coal in order to generate the same amount of heat, you need actually 5 million kilograms, no? So, ang ratio nila is 1 kilogram is to 5 million kilogram. So, imagine, ano mo, no? Of course, ang igamit ani nga heating value is 17. So, medyo lower class po siya ng coal. But, so imagine nimo that is why ang nuclear power plant has cheaper amount of energy. No? Ang cost sa energy niya is cheaper compare sa other sources. Okay, for bituminous coal and anthracite, again, these are grades of coal. Okay, we'll discuss this later on. The higher heating value can be approximated by the Dulong's formula. So this is the Dulong's formula. Okay, 33.823 carbon plus 144.251 H2 minus O2 over 7.937 plus 9.419 S is sulfur. Again, kaning mga C, H2O2, these are the ultimate analysis. And then you subtract the amount of water heat of vaporization, you can get the LHB. Okay, so these are the major coal deposits of the world. So these are the countries that contain the largest amount of coal reserves. So the first or the largest coal deposit is situated in Asamandapet in the United States. Okay, so this is the USA. Ang Philippines is this one. This is the Philippines. This is the USA. So USA has the largest coal deposit in the world. So kaning orange mo ni ang anthracite and bituminous coal. So kani siya mang kaning anthracite, bituminous mga type mga grade ni siya or rank sa coal. Lignite is the lower class nga coal. So the next is Russia. So ang Russia is this one. So kita dyan niyo diri daghan siya og reserve. Third is Australia, 149 billion tons. So this is Australia. Naghan po siya coal. Fourth is China. So if this is the Philippines, ibabaw na to is Taiwan and then China. No? So China has also 142 billion tons of coal. And the fifth one is India. So somewhere here, India. No? Africa, apoy gamay somewhere here. Okay, how about the Philippines? Do we have coal deposits here? Based on the map, mga green man, night din eh. We have actually 348 million tons. So, compare dyan din yung fifth na country is 106 billion. Kita wala kita kaabot og 1 billion. So, that is why we just import coal, no? Sa atong power plant. Usually, ang nakaduol is diri Indonesia. Okay? So, this is how coal is formed. So, from the plant debris, no? So, it is buried underneath the ground. So, due to the extreme heat, no, sa Earth's crust na to, and pressure, becomes peat. And as it matures, no, over time, it becomes lignite. Again, neglect na lang ninyo ning kaning mga mid-kuan, intermediate. So, ang main nga grade sa coal is lignite sa bituminous and anthracite. So, magkataas ni siya, magka-mature ni siya, and then magkataas ang iyang carbon content. And so, the highest carbon content is anthracite. So, no wonder mo na ang pinakagahi, no? So, magkataas ang imo ang carbon content gani, gahi po siya, hard siya, but may mo siyang brittle. Okay? So, kani, and also, kani siya somewhere here, mga kuan pa man ni sila, mga dili pa ni sila mature. So, tag-as pa ni sila og moisture content, no? Ang lignite peat. Okay? But as they mature, ang kagamay na ang iyang moisture content. So this is the depiction of the 4 classifications. Kanimo nimong peat, lignite, sa bituminous, no? Kaabot sa anthracite, nimo na siyang shiny nga again anthracite. So this is ranked by ESTM, no? The highest grade of coal, so it has 86 to 98% of fixed carbon. And it is a shiny black, dense, hard yun siya, brittle coal. So it is slow burning and has heating value just below the bituminous coal. So the bituminous coal contains 46 to 86% of fixed carbon. So mas gamay siya og carbon content sa anthracite. And 20 to 40% of volatile matter. But so magka-mature po siya, magkagamay po na yung volatile matter. So ang bituminous coal has higher volatile matter than the anthracite. So the next rank is sub-bituminous coal. So mas lower na siya og heating value than the bituminous. And it has high moisture content, 15 to 30%. The lowest grade of coal is lignite, from the Latin word lignum, which means wood. So the remnants of wood fiber are often visible and it has very high moisture content of 30%. So lignite actually has high moisture content and a lower heating value. So there are 2 types of coal analysis. You have ultimate analysis and the approximate analysis. In the ultimate analysis, the chemical elements of the coal are determined by its weight, percent weight. So mo ni ang content, no, chemical element sa imo ang coal or any solid fuel. So you have the acronym CHON-SO. So you have carbon, hydrogen, oxygen, nitrogen, sulfur, ash, and water. So the ultimate analysis facilitates, so gamit ni siya sa combustion calculations, no, wherein you can get the critical air fuel ratio, the mass of the flue gases, no, magamit nimo ang ultimate analysis. So there are also types of ultimate analysis. You have as received, air dried, dry, ash free, dry mineral matter free. So pwede nimo siya i-convert, sample kung air dried ang given. So pwede nimo siya i-convert to dry ash free. Ano diri using this conversion factor. For the approximate analysis, determines the mass percentage of fixed carbon, volatile matter, and moisture and ash. So kani siyang mga components ang gina-determine sa approximate analysis. So but the approximate analysis is useful in the design of the furnace, no? It facilitates the determining the burner locations along with determining the amount of coal required for generating a quantity of steam. So actually, kaning mga analysis ng imong coal, ang imong types of coal has a significant effect sa imong design sa imong ang boiler and sa imong other components sa imong ang plant, no? So dili ka pwede nga bisag unsa lang imo ang waon, no? Dapat i-determine na nimo ka magkuha og sa imong source of coal para nakay consistency sa imo ang raw materials. Kay ang imo ang plant is designed man based on that material. No, kay kung high moisture content, so napo na sa significant effect sa imong efficiency sa imong plant, no? You need greater amount of heat, no, para pag air dry ana niya. So and so on. So Let's proceed with the combustion calculations. So combustion actually this is a chemical reaction in which chemical energy in the combustible is converted to heat energy. So ang chemical energy sa imo ang fuel is released by combustion and it produce heat. So there are three main ingredients in order for combustion to occur. First, you need fuel, oxygen, usually air ang ginagamit which has 23% by weight oxygen and 21% by volume and a source of heat. No? So you need to balance the reactants and products. So for solid and liquid fuels, these are the three main elements no nga mo that are combustible: carbon, hydrogen, and sulfur. So you need to balance the number of moles sa imong reactants and products. For gaseous fuel, you have hydrogen, carbon monoxide, and methane. And for hydrocarbons, you can actually use this formula no, to determine the number of moles sa imong reactants and products. Okay, let's focus with these three elements: carbon, hydrogen, and sulfur. So carbon, when it reacts with oxygen, it produces carbon dioxide and releases 32.78 megajoule per kilogram of heat. Okay? So kung i-compare nimo sa hydrogen, ang hydrogen will produce 141.95. So mas dako jud ang hydrogen, but gamay ra man pud ang iyang composition as compared sa carbon sa imo ang coal, for example. So that is why significant jud ang amount of carbon. And ang carbon dioxide, ang imong carbon, there are times nga dili na siya madiretso to carbon dioxide. Sometimes two-step yung process. It becomes carbon monoxide and then carbon monoxide will react again with oxygen to form carbon dioxide. But ang yung heat na ma-release is 32.78. So ang imo ang carbon dili man gid pure oxygen ang imong ginakompose ni air man. Now ang air nimo has 3.76. You need 3.76 kilomole of N2 para ma-forma siya nga air no for 1 kilomole of oxygen. So therefore, dapat na ay nitrogen sa imong reactant and products. Kaya ang nitrogen nimo dili man siya mo react, no? So you need to add this one, 3.76 N2 diri og dani to balance out. So asa gikan ning 3.76 gikan ni siya sa kay ang air nimo 21% O2 man and 79% N2 by volume. No? So para ma-forma siya nga air, you need 3.76 mo nang kani. Ani diri. And then ang imong air fuel ratio, which is the mass of air over mass of fuel, but ang imong mass nimo is just equal man asa sa number of moles times molecular weight. Wherein ang molecular weight sa air nimo is 29. So you use this formula in order to get the air fuel ratio for a certain fuel. Example, you need to combust methane with air. So ang methane nimo, ignore sa ng nitrogen. Ang methane, when it reacts with oxygen, it will produce carbon dioxide and hydrogen. So in order to balance out, ang carbon is 1. So balance na siya. Hydrogen is 4. Nya 2 ra man na diri, so nang multiply ka 2. And then i-balance nimo ang oxygen 4. Nya diri kay 2 ra din siya, 2 initially. Nya diri kay oxygen kay 2 plus 2 4. Munang ga times kay 2 diri. So, since naa kay 2 moles of oxygen, naapod kay 2 times 3.76 N2 which is 7.52. Complete na ni siya. So, ang air fuel ratio nimo will be manigi kaning 9.52 mo na ang number of moles of air kay kuan man na siya 2 plus kani 2 ni sa oxygen 2 times 3.76 7.52 mo nang 9.52 times molecular weight of air over 1 mole sa methane times molecular weight ani 16.04 mo nang 17.19. So in general, you use this equation to determine the number of moles sa imong reactants and products for hydrocarbons. So that for coal nimo, kaya ang coal nimo usually given by ultimate analysis. So hatagan ka og amount of carbon, amount of hydrogen, amount of sulfur. Now kaning 11.51 asa man gikan, no? So mag-start balik ka dito sa carbon plus O2 will result to carbon dioxide. Ang 1 mole ra ang O2 nimo. So 3.76 N2 ang needed nimo. So ang number of moles sa air is 4.76 times 28.97 divided by molecular weight sa carbon 12 mo ng 11.5. No, 11.5 mo na siya. And then for hydrogen and kani for sulfur. So try to kuan ni siya. Pakitaw ninyo nagikan. Kuha ra ni siya ninyo dito sa combustion stoichiometric equations, no? Pila ang air nga needed to combust carbon. So mo ni siya. Air needed for hydrogen, for sulfur. And then minus ka ani because imong carbon na man na siya oxygen content pod. Okay? And then the total dry air, no? Total meaning ang actual kung nakay excess air, imo ra na siyang i-add diri. So mahimo ra na siyang theoretical air times 1. Sample 20%, so 1.2. So this is the excess air's actual minus theoretical over theoretical. So you have the term equivalence ratio. So pasabot ra niya actual air fuel over theoretical air fuel. Kung greater than 1 gani, pasabot niya lean mixture. Lean gani meaning excess daghan ang air. Kung rich mixture, mas daghan ang fuel. Again, you have table 3.3 na sa book, no? Kuan ra ni siya, mga combustion equations ra ni siya. And the number of moles. Napod gali day air required 11.51. Okay, so kani nga mga equations na ni sa book. So gamit ni siya in order to determine the amount of air and the amount of flue gases. So sample, you have this one here, the weight of dry flue gases. So makuha nimo ang weight sa flue gases. So kung makuha nimo ang weight sa flue gases, makuha pud nimo ang size nga fan nga imong gamiton. Kaya mo man ang fan man ang mag-produce aning amount of flue gases man dinhi. Ang fan nga mosuyop ani, induced fan, okay? Or kaning amount of air, balik ta diri, ang amount of air kani naman kay amount of fuel. So multiply na nimo ang kani by the amount of fuel, makuha nimo ang mass of air. So kung nakay mass sa air nimo, makuha pud nimo unsa kadako ang fan nga forced draft fan nga imong gamiton. Okay? And this one is the heat release in the furnace. So gamit po ni siya, no? Kay mo man ni ang heat nga ma-produce sa imo ang during combustion. So mo ni ang i-absorb sa imo ang water tubes. But again, naman na yung mga losses, right? So dili gini tanan ma-absorb sa imong tubes. Pero na gikan diri, so maka-calculate na po nimo during pilay amount sa heat due to radiation, heat due to convection, ano. Okay? So let's have an example. You have an ultimate analysis of anthracite. So carbon 90, hydrogen 3.3, oxygen 3, nitrogen 0.8, sulfur 0.9, ash 2%. Calculate the weight of theoretical air for the complete combustion of 1 kilogram of fuel. So actually, you need to get the air fuel ratio and then multiply by 1 kilogram kung ano nimo ang weight of theoretical air. So if the excess air supplied is 20%, find the percentage composition of dry flue gas by volume. So ang gipangayo ani is percentage, so percent by volume. No, so in order to get the unsa man ang mga flue gases. So ang carbon nimo will produce carbon dioxide, hydrogen will produce water, sulfur dioxide. So these are the three. Of course, ang N2, apil na siya, plus N2. 4 flue gases. Ngayon, paunin mo tong total volume sa flue gas para imo imong dividend, imo ang divisor. No, para makuha nimo ning percent composition. Okay? So, first is theoretical air. You use this equation. Plug in naman ni diretso, you get 11.4 kilogram of air per kilogram of fuel. So, kung pakitao nimo ang total dry air, since naamang kay 20%, imo ra na times of 11.4 times 1.2, so mo na ni ang total air nimo, 13.68 kilogram per kilogram of fuel. Okay? But since ang ipangayo sa number 1 is theoretical air, so ang answer sa question 1 is this one, 11.4. And then for the next question, you need to get the value of this. This is the mole of flue gases. So you have C over 12. So mo ni ang amount of carbon dioxide, sulfur dioxide, and N2. Okay? So you need to get this one, the moles of dry air. Oh, yeah, the moles of dry air. So ang moles of dry air is just mass of dry air over molecular weight, which is 0.472 moles per kilogram fuel. And then, so naana ni siya. And then, the moles of dry flue gases, CO2. So, ang CO2 nimo is kaning nga component. C over 1,200 kay over 100 man. So, makuha nimo nga ang CO2 nimo produce is 0.075 moles per kilogram fuel. And sulfur dioxide and nitrogen. Now, the nitrogen in the total air is, pilagala ito, ang mass of dry air nimo is 13.68 times 0.79 because 79 man by weight. By volume ang nitrogen, no? Sa air. So, mo ng 0.373 moles. So, the excess oxygen, kani siya, excess oxygen man is 0.0164. So, ang excess oxygen is, kung ano na siya, dry air, 13.68 minus 11.4 minus the theoretical over 32. 32 is the molecular weight. Therefore, makuha nimo nga ang total mole of, plug in na rin nimo ning mga value dire. No? Makuha nimo nga the total mole of flue gas is 0.465. So, kani 0.075 divided by 0.465, makuha na dahil nimo ang percent composition. So, based dire, 80% of the flue gases is nitrogen, followed by 16% carbon dioxide and 0.06% sulfur dioxide. So, gamay kaya ang full sulfur dioxide. So, it is okay. Okay? Corrosive man po yung sulfur dioxide. So, nana lang siya paggamit sa equations. So, in your project, you need to determine the amount of air and amount of flue gases. Okay? Dito na dahil gamitan na dahil ninyo in order to size your fans ninyo. Okay? That's all.